I've heard a few YouTubers say it's no big deal. I'm a former ASE certified mechanic. I'm also a aircraft and power plant mechanic, certificated aircraft mechanic. This is not an easy job, and I would say if you're going to do it yourself, allocate plenty of time. You know, you need to have a backup vehicle, in my opinion, because this thing's going to be on jacks for a little bit, and you need to take your time, go slow, and just pay attention to everything you do. Make sure you sequence what you take off and go back on in the proper order, because it is it's not a cakewalk. So anyway, just want to share that with you. Again, Ford really knocked it out of the park with this engineering marvel. I'm working on a 2019 Expedition with the godforsaken 3.5 liter Ecotech. Just did the can phasers, got the timing cover on, working on and getting the rest of the components put back on that I had taken off previously. And currently I am working on the crankshaft pulley installation. I hope you can see what I am trying to show through the mirror. But the crankshaft has some non-threaded portion quite a ways in before you get to the threaded portion. And the reason I point this out is because the toolkits that you will get from the major parts houses, aftermarket parts houses like O'Reilly and AutoZone, will not work. Here is one kit from O'Reilly, and it is kit number 67006. It absolutely will not work, even though this is the right thread and matches the thread of the crankshaft pulley bolt. You will see that it bottoms out before it ever engages. So there it is, all the way in. So that won't do you any good. And just so everybody knows, those threads, that bolt, that crank pulley bolt, is a 12 millimeter by 1.5 millimeter thread pitch. It's called an M12 by 1.5, and you could see it right there in that kit. This other kit, and it's part number 67306. So it has the correct, also, it has the correct 12 millimeter M12 by 1.5 bolt, but when you try to install it, you will engage, you can engage about maybe half a turn. So it's grabbing the threads that are inset into the crank, but I back it out a half turn, and I can then I can pull it back out. So it's only engaging about half a turn. So what I did was I just took a thin screwdriver and I put it in and marked until I got to the threaded portion of the crank, and I marked it with that black magic marker. Then I put it in the rest of the way until it bottomed out inside the crank, and you get about that. And just for comparison's sake, and I realize this is the wrong washer on here, but here's what that looks like, in case that matters to you. So anyway, that total length is about that right there, and that's about right, because when you look at the crank pulley, most of that is going around the crankshaft, and so you're dealing with a very limited amount of material between the face where the washer goes right here, and then where this butts up against the crank. So all that makes sense. And what that led me to do is, again, I've looked all over. I tried to find a piece of 12 millimeter all thread. That's not to be found. You can find all thread in Lowe's. So what I'm going to do is I am taking this 12 millimeter bolt. In this kit, it's this one right here. I'm taking that, and the reason this won't go in but a half a turn is because the non-threaded portion of the crank, the threads here, you can see that they're larger diameter than this. And this is bottoming out onto the crank. So what I'm going to do is I'm going to take a grinder and I'm going to grind that off so that it is smooth, so that I can utilize this, all the threads of this, into the crank to engage the crank thread, the internal crank threads. Then once all this is shaved off, then this will fully go in and then bottom out inside the crank. That will give me enough surface here to put my nut and bearing on to pull the crank on. So anyway, just wanted to let everybody know how to get around this if they can't find an installation tool that works. Again, go with 67306. You're going to have to buy it, because once you do this, you've destroyed the loaner. So you're going to own it, unless for some reason you can find a 12 millimeter bolt that long, which I've been unable to do. You know, I live in a fairly industrial area where I should be able to find it, I think, if anybody can. So anyway, hopefully that helps everybody. I'll do I'll let everybody know how it goes after I get it installed. Okay, here is the bolt. Hopefully you can see that all right, with the threads removed. And just to give some comparison, here's the old crankshaft pulley bolt, and that's how much I ground back the threads to. And just as an aside, I want to point out that I got these heavy-duty disposable gloves from a discount store called Ollie's or Aldi's or something like that. It's like a Big Lots of sorts. Found these there for $8 and 25 pairs, and I'm extremely impressed. I priced these things at O'Reilly and AutoZone, and you can't touch them for this price. And I've reused this pair that I'm wearing. I've reused them several times, probably 8 to 10 days I've been using these. Turn them inside out when I take them off, put them in front of the fan, get the sweat off of them. So just a little tip to everybody. Anyway, about to put this in, show you how it works. Okay, just so everyone can see what the modification enabled me to do is, okay, now I've got threads engaged. I'm pulling on it, won't pull out. And now I'll thread it in, just so everybody can see what removing those threads did. Okay, now it's bottomed out, but you can see it's not bottomed out on these threads that the nut will go on to pull on the crankshaft pulley. It's actually bottomed out inside. So I wanted you to see what that modification enables you to do. So I want to show what I'm doing here. I'm marked. I stacked a bunch of washers. You can see I've got the nut that's going to tighten down and pull in the crankshaft pulley. I've got it, but I've also got some washers. I've got some washers between that bearing and the pulley, and I'll explain why in a little bit, but I do want to show that I also marked the head of the long bolt that I shaved off, and I did that because as I draw it down, what I did was I stacked enough washers on where I got full engagement of those threads, but yet I had this nut way back to the back. I did that so this 1 1/4 inch socket would work, since it's not a deep socket. And the reason I marked the head of that bolt is because I put the bolt in, I bottomed it out, then I backed it off just slightly so it wouldn't damage the crank in any way. And then as I draw this crank down, and you can see, hopefully you can see that it's drawing down as I ratchet it. Hopefully you're able to see that. It's slow progress, but some is better than nothing. And I won't bore you with doing this the whole time, but I wanted you to see that while I'm doing that, I do check the head of that bolt to make sure that it also isn't tightening that bolt down, because I do not want it damaging the crank, in spite of the fact that Ford engineers were utterly incompetent when they designed this engine to do these cam phasers, sometimes as early as 30-something thousand miles. Utterly ridiculous. And then and then here I am, a do-it-yourselfer, doing this job because Ford won't cover this, in spite of the fact that it's clearly a manufacturing defect, and they're worthless 36,000 mile, 3-year warranty, 5-year 50 powertrain, if it's got that. I don't even know. I mean, the company's just worthless for designing something like this and then not standing behind it. They say Ford quality is job one. No, they've proven quality is not job one with them. It may be 9 or 10. Who knows if it's even that high? But I'll give you a progress update here in a little bit. Okay, so my nut has pulled in enough that my shallow socket will no longer engage the thread. So what I'm going to do is I'm going to pull the whole thing out, and then I'm going to stack enough washers in, the amount of washers that are needed to get this jam nut back here near this bolt head, so that I can once again use my socket. More to come. Okay, here you can see my initial stack of washers. I've got a big nut on there just because it was handy, and so I used it. Anything will work just to take up that space so that I can get the nut towards the back of the bolts. And then what I'm going to do is just I'm going to get now enough washers that would fill up this gap, and stack them on the end here, and then that will let me pull this thing back and know that I still have plenty of threads engaged in the crank to pull that thing down. More to come. All right, I don't want to beat a dead horse here, but I just want to make sure everybody understands the principle. So I've got the crank in that far. Hopefully you can see that. You can see that my socket is about to not be able to engage the nut due to it bottoming out against the bolt head, and so I'm going to stack some more washers on it to get that nut back to where it's fully engaged with the socket, and I'll show you what that amount of washers eventually looks like. Okay, just showing you that it took about 2 finger widths of spacers between this bearing and the crank pulley face. This did work very well. I'm pleasantly surprised. Unfortunately, you will have to modify that bolt like I showed you by grinding those threads off. And anyway, about to do the torque sequence on the crank pulley using the belt to hold the pulley, as I've seen some of the guys here on YouTube do. And that's, as far as I know, about the only way to get that done. I forgot, but the last tip I want to show you is I talked about winding the belt around something solid on the engine. Just want to show you what I did. I used the AC compressor stretch belt. Again, another brilliant Ford design, and wrapped it around where it normally goes, and then tucked it inside itself right there, anchored it up here. But I wanted to show you also that when you go to do this tightening sequence, it's I think 37 pounds plus 90 degrees. When you do that, you're going to have some turning of this crank. The only real way to know that you got the 90 degrees is to mark the crank pulley and the bolt. And you'll see that I've got, I put a little V-notch on the crank pulley where that black marker line on the bolt flange was, they were aligned. And so that's, to me, that's a foolproof way to know that you've got that 90-degree rotation after the torque value. I did that also on all of my front cover bolts. I marked those just to make sure that I didn't miss any of them. And I would recommend, especially to, to anybody basically, but I would recommend especially to some of the novices, do that. It's just a foolproof way to make sure that you haven't missed something. You can see I had a bolt head there, but you can see that mark on that bolt head. I marked them all up and down, and then sorry about that. And then I could see the amount of rotation I had after the torque value. So just a tip. I hope that helps somebody.